So there's some company and its share price was initially worth £100 and then it publishes its financial reports and we know that P is decreasing at a rate that is inversely proportional to root P. So you don't need to do this, but if you wanted to, you can kind of think about this graph. And we've got T minutes after publishing their report, and we've got the share price. And we know that the share price starts at 100 and then it decreases. So it's like plummeting, something like that. And let's try and decode what this means. So P is decreasing at a rate that's inversely proportional to root P. So what we really mean by P is decreasing at a rate is with respect to time. So that means the rate of change of P with respect to time is inversely proportional to root P. So that means it's equal to K over root P, where K is some constant. Now it's important to realise that because it says P is decreasing, we know that the graph is going downwards with respect to time. So that means that at any point here, the derivative dp by dt is going to be negative. The rate of change of P is negative. So that means that this right-hand side must be negative. So because root P is always positive, we know that K is going to be negative. Before we solve this differential equation, let's look at this other piece of information we've got. We're told that after 20 minutes, the share price is 91. So we know that when t equals 20, P equals 91. And we'll only use that later on in the question. I guess we also know that when t equals 0, P equals 100, because we're told that the share price was initially worth £100. So what we're going to do is we're going to solve this differential equation using the separation of variables method. So we're going to get all the p's on the left hand side. So I'm going to times through by root p. And I'm going to times, so we're going to have that. And I'm going to times through by dt. So we're going to have root p dp equals k dt. So I've separated the variables. So that means now I can integrate both sides. So on the left hand side, I've got the integral of p to the power of a half. And on the right hand side, k is just a constant, so that integrates to kt. It's really important that you realise on the right hand side we're integrating with respect to t, so integral of k is kt. And then we'll add on the constant of integration to the right hand side. And then if we integrate on the left hand side, we're going to increase the power by 1 and then divide by the new power. So really we've got 1 times by p to the power of a half. So we're going to do 1 divided by 3 over 2, which is 2 over 3. And then at this point, we can times through by 3 and divide by 2. So if we times through by 3, and then divide through by 2, so our next job is to find out what are the values of C and K. Now you could just sub in what we know. We know that when t equals 0, P equals 100, and when t equals 20, P equals 91. But we can make our lives easier because I've realised that 3 over 2 times by K is just another constant. 3 over 2 times by a constant is just another constant. So we might as well write that as AT, where A equals 3 over 2K. And same here, 3 over 2 times C is just another constant. So we might as well call that B. So B equals 3 over 2C. So next we should probably rearrange this to get P the subject. To do that, I'm going to raise both sides to the power of 2 over 3. Because if I times those two powers together, we'd get P to the power of 1. So if I do that on the left hand side, I need to do that on the right hand side too. So I know that P is equal to AT plus B to the power of 2/3. So next I'm going to sub in when t equals 0, P equals 100. So t equals 0, p equals 100. So that's going to say that 100 is equal to at is going to be 0, so b to the power of 2/3. So we can find out what b is by doing both sides to the power of 3/2. So the reason I'm doing that is because if I times those powers together, we'll get b to the power of 1. So we need to do the same on the other side as well. So we'll get b to the power of 1 equals 100 to the power of 3/2, which is 1000. So that tells me that p is equal to 80 plus 1000 to the power of 2/3. And then finally, I'm going to use the fact that when t equals 20, p equals 91. So we're going to have 91 equals 20a plus 1000 to the power of 2/3. And again, I'm going to raise both sides to the power of 3/2, because that will mean that I'm going to have 20a plus 1000 to the power of 1 on the right hand side if I times those powers together. And I'm going to have to do the same on the left hand side to keep it balanced. So I'm going to have 91 to the power of 3/2. And then we can just rearrange this to make a the subject. So a is going to be equal to 91 to the power of 3/2 minus 1000 divided by 20. So a is approximately equal to minus 6.60 to 3 sig fig. So that tells us that p can be written as minus 6.60t plus 1000 to the power of 2/3. So we've achieved what they wanted us to do, and we found an equation for p in terms of t.